Alright people, welcome back. We're looking at inverse functions. This is a very straightforward lesson. I've got some information for you here in front of you where you can pause the video and jot it down. Just in general, this whole concept of inverse functions is taking what a function presents, and then the inverse functions is really just the opposite operations within that original function. Okay, if that makes sense, great. If it doesn't, these next examples are going to help out a lot. So here, displayed is a table, okay, of an inverse of a relation, x and y. What they're asking me to do is produce or graph the inverse of that relation. Okay, so let's go and do that here in blue. Now the one thing that I need is to have my own set of values, my own table. One thing I do want to mention is that these ordered pairs, right, that make up this relation are graphed here. Alright, so again, I've got my relation, my ordered pairs, and now for my inverse. Okay, I'm going to introduce this little -1. Okay, it's very informal now, but I will formalize it in a little bit. Excuse me. But just kind of working you guys into it in a little bit. So for me to produce the inverse of this given a relation, I simply switch the values. All these y values will now be here for x. 4, 2, 1, 0, 1. All these x values from the original relation will now be y values. -1, 1, 3, 5, 7. And now I simply go and plot these on this graph, see what we get. Okay, so I got 4, -1. Okay, 4, -1. I've got 2, 1, 2, 1. I've got 1, 3. I've got 0, 5. And I've got 1, 7. 1, 7. Okay. All right. So if you go ahead and take a look at this, you can see that there is a reflection across the y-axis. I'll go ahead and kind of draw this out here for a sec. Okay, and that's by design. That's one of the outcomes of this relationship. Excuse me. So yeah, this is a product of their relationship. Okay, a given relationship and its inverse, that they will be reflection images of one another off of the line y equals x. Alright, let's go and push forward here. Hopefully this is a shorter video than yesterday's. I think you guys deserve it. Alright, use inverse operations to write the inverse of the following function. Alright, so we don't miss a beat, I'm going to rewrite it. Now earlier in the notes, you can look back at the video, they did suggest the switching of y and x. Okay, so the first thing I want to do is go from function notation to equation notation. Now, okay, what I can do is trying to get clever here. Let's see, inverse. Okay, we'll introduce this little symbol here. It's like a little circle. Okay, I'm sure you guys might have better suggestions, but this is initiating the inverse process. So I simply replace y and x. Okay. Now, if you look back at the notes, it does tell you to solve for y. So here I would add. Let's go ahead and add 1/7 to both sides. Why? Because I want to solve for y, and solving for a variable means you want to isolate it. So it does cancel here as we would expect, and we're left with what? Y equals x plus 1/7. So there's the inverse process pretty much complete. However, they do want what? An inverse to this function, so you must terminate or finish with a function. So I'll switch the y back to x plus 1/7. However, if you look at this f of x, it's different than this f of x. So how do we distinguish the two? Well, since this one underwent the inverse process, I'm going to introduce a -1, kind of like an exponent. However, people, pay attention, you do not say f to the -1. You call this f inverse. This is not math. This is just notation. Okay? So when you see this, this is f inverse. And we move on. There it is. All right, next up, very similar problem. Use inverse operations to write the inverse of this f of x. So let's go ahead and rewrite the darn problem. It's not going to kill us. So we're going to go from function notation to equation. Okay. We're going to begin that inverse process. I'll even put it in quotations. Why? Because it's not universally accepted. It'll be our classroom language. But at this moment, I'll simply switch x and y and leave everything exactly the same, so that I can begin now to solve for y, right? First thing I should do here is what? Add 5. I'll go really slow. Why not? This stuff's not bad. Plus, some of you guys might benefit from this. Equals y to the 4th. Why? Because this canceled here. Right. The next thing I want to do is, you guessed it, multiply by 4. Again. Now, I got to be careful, right? The entire right side is being multiplied by 4 and the entire left side. So I'm going to really use those parentheses. But they serve a purpose. So anyways, they cancel out here and I'm left with y equals 4x plus 5. Here's my equation. Technically, I didn't say that in the other video, this is not just any y, it's kind of like an inverse y. But we'll formalize that here by returning to function notation, 4x plus 5, and we will remind our readers that this has undergone the inverse process, therefore f inverse of x is equal to such and such. Alright, next up we have graph f of x, then write and graph the inverse. Alright, so I'm going to bypass this. You guys have graphed this since Algebra 1 or maybe even before. Okay, I'm not going to focus on that. It says then write and graph the inverse. So they do want to see that relationship, so I might actually do that towards the end here. But for right now, let's go ahead and really capitalize on what we are able to do now, which is perform this inverse process. Okay, so we got y equals 5x minus 1. Right? There's our little symbol here. And we've got x equals 5y minus 1. Let's go and solve for y. This time I'll do the math a little fast. I'll add 1 to both sides. I'm going to divide by both sides, and I got y equals x plus 1 divided by 5. I'll put that in parentheses, make it look nice and neat, and I will return to function notation and make it clear that this is not f of x, but f inverse of x. Alright? So let's go ahead and graph these bad boys. 5x minus 1. Let's see here. Okay, so we got 5x minus 1. Enter. Alright, now we hit tab. F of 2 is the other guy, which is our inverse. X plus 1 over 5. Okay, x plus, what the heck did I say? X plus, go check here. X plus 1 over 5. X plus, whoops, plus 1 over 5. Enter. Alright, and if you really look closely here, you can see that there is this y equals x imaginary line that the two reflect off of. Okay. Alright, let's go ahead and move on here. And this last problem says a clerk needs to price a cashmere sweater returned by a customer. The customer paid a total of $222.36. That included a gift wrapping charge of $4 and a 9% sales tax. What price should the clerk mark on the tag? Alright, so if we set up a problem like this, okay, informally, alright, and this is kind of my scratch work, I would say that the cost, okay, of this product, this cashmere sweater, is the same as for every dollar that I spend. And this is the way I think, this is kind of my scratch work. Okay, I would spend $1 for what? For each dollar essentially that they're charging me for the item plus the $4 additional for this wrapping charge. Okay, now comma, this is without tax. So the fact that there is a tax tells me to do the following. It means to consider that the actual cost then is not the dollar for dollar, but really I'm paying $1.09, right? Because of the sales tax for each what dollar that is charged for the cashmere sweater, plus for each of the $4 that is being charged for the wrapping. Okay. There's different ways and schools of thought on thinking about that. We've covered this in the past, but that's kind of the approach that I'm taking here. Okay, so essentially, if I multiply by 1, you retain just the dollar value. However, by putting 0.09 to this dollar value, you're actually including the tax. Okay, so kind of think about why it's being set up this way. That's very important. Beyond that, the math should be pretty straightforward. Okay. All right. So let's go and continue. So if I have this set up, I can distribute, and I have what? $4.36. Now again, it's always important to go back to the question. They're looking for P price, so now I'm looking to isolate. Okay, so I'm going to subtract the 436. So I got C minus 436 equals 109P. Right? And you guessed it, I'm going to now divide by 109, so I have C minus 4.36 over 109 equals P. Okay, so if I want P, now I know, but I must know C. I go back up here and I realize that the customer had paid a total of $222.36, so I'm going to plug that in, 22236. So then, okay, in here I'll go 22236 minus 436 over 109, which equals P. And if we enter that in the calculator carefully, we get $200. And you can go and do that. I'm just kind of boosting the process to save time on this video. What price should the clerk mark on the tag? $200. Mark on the tag. On the TAG. Guys, thanks for your time, for watching. I'll look forward to answering your questions, comments, concerns in class. Have a good one.